So hey everyone, so in this video I'll talk about how we can apply the law of sine in different questions. So this is the first problem. So just remind yourself that we do have the law of sine that we can apply in different cases, but um, we do need a few information. So but before we write that, so maybe I should remind the law of sine. So law of sine is the sine measure of one angle, okay, divided by the side that is opposite to, divided equals the sine measure of another angle in that triangle, divided by the side that is opposite to given that angle, and that is equal to the same for the third angle, okay? So the sine C divided by side C. So in our case, so we are given B is 41. So this is 41. And then A is 48. And then B is the angle measure. B is 35 degrees. Okay. So we want to find the missing part. Okay. So let's go ahead and start writing the ratios and see if that's going to give us something. So I can start with the given angle, that's the only angle that we know. Sine 35 degrees over the opposite side to that angle is 41, so that should be divided by 41 equals, and since this is the other side that I know, so I need to use this angle now, so the sine A over 48. We may just write the third one as well, but let's actually do that. So the sine C over this angle opposite to side C, so that is divided by C. So since we know the sine 35 is a number, this is also a number, so the top and bottom is given. And then in the second fraction, we know the bottom, but we don't know the top because angle A is not known. So which is why we can take these two proportion and do cross multiplication to get what we want. So let's do them. So that should be 48. Like you can multiply these and these in any order that you like. So I start with 48 times this, sine 35. Okay, equals 41 times sine A. So the goal is to get the angle A, so we can divide both sides by 41 to cancel this 41. So let's do that. So that is divided by 41, so these will cancel. So this is something we can simplify if you want to, and then this is going to be equal to sine A. Okay, so let's go ahead and do that. The 48 and then times sine 35 degrees, so that is 35. And then I can make it equal to divide by 41. So only thing that you have to make sure that your calculator is like in degree mode. Okay, so that was, I hope, the case in this case. Anyway, so we got the 0.6 whatever number equal to sine A, right? So let's type this. So the 0.67 and 15. Since we are going to have at least 4 decimal places for the middle rounding, so I'm going to leave it at that 4 decimal point. So, but the question now you have to ask yourself, like, how do I deal with this now? So the sine A equals a number, and I like to get the angle measure of this A. So to find the angle measure, we are using inverse of the function. So in this case, we are going to use inverse of the sine. So sometimes we are going to use inverse of those as well, but we are going to use inverse of the sine function. Okay, so which is basically inverse of that. So you see, if you just use this tool right here, so you will copy everything that you need, and that is equal to 42 point something. So let's go ahead and type that. And then that means the angle measure A is going to be 42.42 18 something, but we want probably gonna get the nearest decimal, so that would be 0.2. Okay, so that is the answer. So sometimes we have to be careful because we may have more than one solution, but how do we determine that? So one of the key features of the sine function is sine values are actually complementary to each other. What I mean by that, so if I know the sine measure of one angle, okay, this is equal to the sine measure of supplementary of the angle. So 180 minus alpha. So for example, in this case, like 42.2, so the sine 42 degrees is the same as sine value of the supplement of this one, so which is basically 180 minus, let me do that, 180 minus 42 point this number. 42.2, right? I just typed wrong. So the 137.8. So why do I need? Maybe because we do have two different sine values that will make the case. So, but let's make sure this is if this is possible. So, and based on this, A might be 137.8. But if I add this number and the given 35, and then angle C, I should be getting something that is lesser than 180 because otherwise it doesn't make a 180, so that doesn't make a triangle. And also, you know, this is 35, so that's opposite 41. Angle A is 48. Okay, so which has to be larger than this. So 42 was larger, and then 137 is also. So maybe we can say angle C. So let's go ahead and try those. Like, let me write the first solution. Okay, so the angle A, we got 42.2, okay? And then angle C, which is gonna be this number plus this number plus this, should add up to 180. So we can kind of find it as well. So let's try that. So 180 minus the angle B is 35 minus angle A 42.2, and that's 102 point something, 0.8. And then side C is what we are going to do now, okay? But how do I deal with that now? So we can just do the law of sine that we start with, that we can choose now different fraction part. So since we know this fraction, and this is actually now what we want, right? Because C is what we are looking for. So we can take those two. So I can multiply this number by C because you know when you do cross multiplication, you multiply those numbers. I don't want to clean this screen, but make sure you kind of see what we are trying to do now. Okay, so sine 35 times C equals 41 times sine C. But C is actually, we know now the angle measure, which is 102.8. So that is why I can just replace with that. But I think I should have do the 4 decimal places. So maybe that's why I may not get the actual concrete answer, but that should be fine because I'm just rounding it to the nearest decimal right now, nearest 10 point. So that will be 108, 102.8, right? Okay, so then this C is gonna be the product of these two, and then we have to divide that by sine 35 to get that. So let's go ahead and do this part. So 41 times sine 102.8. This is the product of these two numbers, but that is equal to C times sine 35. So we should divide by sine 35 to get C alone. And that will give us 69 point something. And that needs to be my answer. But if you round it, so that will be 70.0 to the nearest. Okay. Yeah, okay. So the question that you might be asking, do I have another solution other than this, right? So maybe we should take that into consideration as well. The reason why we need to check, because we may have the angle measure of A 137.8 instead of 42 point something. So let's consider that case to see if that is also possible. But let me clean this mess. And leave those. Okay, so the angle measure A, B doesn't change because we have A as two different choices. So what we are gonna try now, if A is 137.8, and then this is 35, so we can just add these two angles. So let's clean this one a bit. So 137.8 plus 35. Okay, so 172.8. But if you subtract this from 180, so that will be angle C. So which is like 6.2, I guess, which you can easily subtract. So that means C is angle C is 6.2, right? So let's go ahead and try that. Is C, angle C is 6.2, because if you subtract this from, no, this is 7.2, right? Because that's 73, yeah, 7.2. If you subtract from 180, you got 7.2 for angle C. So that might be another case. So let's plug it now into this equation. So what we want is the second case, sine C, sine 7.2 over side C equals, angle A doesn't change, so I can just still use them. And angle A was 35. I mean, angle A is right here, did change. We got angle A as 137.8. So the sine 137.8 over, right, angle A is opposite to 48. Okay, so now if I use the cross multiplication in this case, so the C is going to be this number times this number divided by this number, so which we've seen a few times. So you can just write it 48 times sine 7.2 and divided by sine 137.8. So let's plug this into the calculator now. So 48 times sine 7.2. Okay, divided by 137 sine 137.8. So which is 8.9 something, right? So that is my side C. So let's go ahead and try them as our second solution. So we got the angle A 137.8, and then angle C 7.2, and then side C 9.0. So I hope that makes sense. So we do have two different solutions in this case. Sometimes we may not have that many solutions. We may have just one solution, sometimes zero solution. In this case, we had two solutions, so which is why it took a bit longer, okay? So I hope that is clear. Okay, so this is another problem, which is a bit challenging. So it's a word problem. And we are given that the Abdullah sees like two different balloons, right? And then we are given the distance for from him for each of those balloons. So this is for 945, this is 670. This is a vertical line in between, and the angle measure is given between that vertical line and the distance between Abdullah and each balloon, right? And the question is asking how much higher is the balloon on the right from the one that from the left, which basically means we are looking for the distance between this point to this point. This is the vertical distance between Abdullah and the high balloon. And this is the distance between the smaller one. So we are looking for the difference between these two ones. So like if I name it this way, A, B, C. So the question is asking AC minus AB. Okay, so that's the question. So as soon as we understand what's being asked, so we can try some other ways. I will say we are given in this right triangle the hypotenuse, and now if you want to find the AC, which is the side that is next to 36 degrees, so we can use the cosine, definition of cosine. Cosine of a angle, in this case 36, I can take, is equal to adjacent side, which is AC, for this triangle of this angle, divided by hypotenuse, which is 945. Okay, so that is my definition of the cosine. And if I multiply both sides by this number, so I can get AC itself. So the AC is equal to 945 times cosine 36 degrees. Okay, and for the second one, if I look at this picture, I have the same reasoning. No, I do need AB. So AB is the adjacent to this 42 degrees, and then this is my hypotenuse. So if I use the definition of cosine in that case, so cosine 42 will be AB over 670. And then from here, so you will get AB equals 670 times cosine 42. Okay, so now if I want to take the difference between these two numbers, which I can just plug into the calculator to do so, so I will get what I want. So the AC is 945 times cosine 36 degrees. Okay, and I can subtract the next one immediately because AC minus AB is what we are looking for, 670 times cosine 42. And that would be my answer. Okay, so this is one thing we can do. We can just round it to the nearest 10, which will be 226.6. So you can leave it that way. But if you didn't come up with this, which actually we have to be doing this in a first approach because that's just the definition of the cosine that we did. Why we use cosine, if you are wondering, because we are given the hypotenuse, and what we want is the adjacent, so which is why those two sides are related with the cosine, so which is why we use that. But as a second approach, which I'm not gonna complete all the steps, but I'm gonna give you at least the starting point. I can use the log sign as well, because the reason why I know one side, I know the opposite angle, and I'm looking for AC, which is why I can actually find this angle. So if you add these two angles and then subtract from 180, or if you subtract this from just 90, so that will be 54, right? And if you do the same thing with this guy, so you will get 48 degrees for this angle. The reason I need those because I'm looking for the AC, which is why I need the opposite angle to use the log sign. Log sign was telling us the sine of any angle, so sine 54 in this case, over opposite segment, which is AC, equals the sine 90 degrees over opposite segment, which is 945. You may write the third ratio, which we don't need because that will give us this side, which we don't really need that. And if you do cross multiply and then find AC from here, so that will be exactly the same as this one, which I will leave for you to confirm that. So if you do cross multiply and find AC alone, so you're going to get the same number as the product of these two numbers, okay? And if you use a log sign in this case, then you're going to get the let's say 48, right? So sine 48 over the opposite segment is AB, so I'm going to write AB equals the sine 90 degrees over 670. So if I do cross multiply and find AB itself, so I will get the same number as this product, and then you can just confirm it as well, and that will be our final answer. Okay, so I hope that makes sense. We did 2 different questions, which was a bit challenging. So I highly recommend you guys to do those steps on your own, and see if you can actually handle those as well. Okay, I'll see you in the next video.